We're going to look at two things, composite and inverse functions, but first we're going to focus on what composite functions are. So we'll basically be inputting a function inside another function, and we're looking at a function of a function essentially. So what's the idea basically? Let's say you do your homework and you get a good score. The hope is that you're going to get a good score on the weekly quizzes that we have for that chapter. And if you do well on all your quizzes, the hope is that you will do well on the big tests that you're going to take. So basically what happens is your test score, we can say, is a function of your quiz score, and your quiz score is a function of your homework score. So essentially your test score gets traced back all the way to the homework score. So first you predict your quiz from your homework, and then you predict your test from your quiz, but your quiz really depends on your homework. So you're kind of thinking of a function of a function. So basically you have an input x, and let's say some function f comes in, grabs this, and when it grabs it, it spits out an f of x. So x gets grabbed and a y value or an f of x gets spit out. Then what happens is maybe another function g comes and picks up this input, because this output now acts as a new input, and then g grabs that and spits it out somewhere else. So you start with an x gets grabbed by one guy, whatever output comes out gets grabbed by another guy, and you end up with a function composition. So the notation for it is you have an input x that gets grabbed by whoever's closest to it first, so it gets grabbed by g, that creates g of x, and then f, the final piece, grabs whatever output was produced, and it's pronounced f of g of x. Or if you have the g first and then this little composition, so the circle is the composition sign, g of f of x, x is closest to the f function, so f grabs it first, and then after f gives the output, g grabs it, and then you get to your final destination. So g of f of x is how this is read. Given these two functions, we're going to find these compositions. So notice 2 is closest to g. G is going to grab 2. You want to find that first. And then f is going to come and grab whatever that result is going to end up being. So first thing you want to do is find g of 2, which is not a new problem. You've done this before. You just put 2 inside of your g function. So 2 squared, which is 4. This is the output that f is waiting to grab. So now you're looking at f of 4. Well, how do I do f of 4? I just go back into the f function and put that in. And when I do that, it looks like I get 8 plus 1, which is 9. So ultimately, f of g of 2 lands me at an output of 9. So there's a two-step process going on. G grabs it, and then whatever it spits out, f grabs that. Let's go to part B. Since f is closest to 2, f is going to grab the 2 first. So now all I have to worry about is f of 2, and then later g is going to come and grab whatever that is. F of 2, no big deal. I take it and I go inside the f function. So 2 times 2 plus 1, that's 4 plus 1, which is 5. So f of 2 is really 5. Now what's going to happen with the 5? The g is going to come in, grab it. So what's g of 5? What's the second step? Put that back into your g function. That's just going to be 5 squared, which is 25. So ultimately, g of f of 2 is just equal to 25. So all we're doing is an interdependence. 2 gets grabbed by this guy, and then the result gets grabbed by this guy. Or 2 gets grabbed by the g first, and then the result gets grabbed by f. Let's do another example. Given this f and this g function, find f of g of x for part A. Well, what's the input? It's not an actual number, it's just a variable. So g is going to grab the x, and then whatever that output is, f is going to grab that. Now notice g of x didn't get an input of a number. If it didn't get an input as a number, then it must be this entire function g of x. So all I got to do is substitute g of x for whatever g of x is, which is just 2x plus 3. So it spits out the entire function itself, and then f is going to come in, grab whatever that is. So where is this going to go into? It's going to go into the f function wherever the x is. So this entire thing, output gets back inside of the f function. So now I end up with whatever that big giant thing was squared plus 1. Well, what am I inputting in there? This whole giant thing, the entire function, 2x plus 3. And I can simplify a little bit. Let's FOIL that out, or multiply that out. So we multiply it all out, combine like terms, and ultimately f of g of x, this function composition, is equal to this polynomial, quadratic polynomial. Alright, part B. Remember, x is closest to f, so f grabs the x first, and then whatever that does, g comes and grabs that. Now again, f of x didn't get a number input, it just got the whole x itself, so this entire function comes and plays a role. What is that entire function? It's right here, it's x squared plus 1. So it didn't output a number, it output the function itself, which g is going to grab. So this entire box goes inside of g, which is right here. Where does it go in g? Wherever the x is, of course. So this entire thing goes inside of g now. That's going to give us 2 times whatever that giant thing is plus 3. Now what is the giant thing that goes in there? It's the entire f function. So I have 2x squared plus 2 plus 3, which is 2x squared plus 5, which is actually my g of f of x function. Now part C says find g of f of negative 1. I can do this in 2 steps. I can say, well, this gets grabbed by f, and then whatever output that is gets grabbed by g, or I can just use this global function, because I know g of f of x is this entire function already done for me, so I might as well just use this result to put in the negative 1 and be done with it in 1 step. Again, I can do it in 2 steps, or say if I have the global function already calculated and done, then that's just going to be just one input, and my answer is 7, it looks like. So again, either do it in 2 steps, get the output, like right here, if I get f of negative 1, remember what the f function was. It was right here, it was x squared plus 1. So I could say negative 1 squared plus 1, that's going to be a 1, 1 plus 1 is 2. Now g is going to grab the 2. Well, 2 goes inside of my g function, which is just 2x plus 3, so in place of the x, 2x plus 3, I put the 2 back in, and I end up with 4 plus 3, which is 7. So I did it in 2 steps like I had done before. Take the negative 1, give it to what's closest, whatever the output is, give that back to g. Or, since you have the global function already calculated in terms of x, just put the negative 1 there, and you have g of f of x already done. Next, we're going to look at finding function compositions graphically. So we don't have an actual function to input things in, we just look at the graph and grab the information we need. So let's look at part A, which says f of g of 1. The first step is always the same as before. G is closest to 1, so g grabs the 1 first. Then whatever happens to that, f comes and grabs it. So now let's go find g of 1 from the graph, since I don't have a function to put it into. G is the red function, the input is 1, so I go to the x coordinate 1, and then to get to my g graph, it looks like I have to go 1 and 2 steps up. So there is g of 1, which is actually a y value of 2. So g of 1 says x coordinate 1, y coordinate for the g function is 2. Once that gets spit out, now f comes and grabs it. So what is f of 2? Meaning the input now for the f function is 2. So I go to the x coordinate 2. And to get to my f function, it looks like I don't have to go up or down because my graph for f goes through that point. So when x is 2, my f function has a y value of 0. So f of g of 1 is just simply 0. Let's go to part B. How about g of f of 1 the other way around? So f now grabs the 1 first, and then g comes and grabs the result later. So let's go do the inside first. F of 1 says go to the x value 1 again, right here. But this time go to the f function, which is the blue graph, and the x-coordinate 1 corresponds to the y-coordinate -1 for my blue function, which is the f function. That's what gets spit out. Now g is going to come and grab that value. So now I have to go to the x-coordinate -1 for my g function, and it looks like my g function goes through that point right there. So it's the ordered pair -1, 0, which means the output or the y value for the g function is 0. So give it the x, get the output y, and then the other function comes and grabs that as the new x value. Let's go to the last part. G grabs the 0 first, and then whatever that does, g comes again and grabs it. Now let's go to the graph. The input is x0. So I'm going to go to the graph and stand at the x value of 0 and go to the g function. Well, the g function goes through the ordered pair 0, 1, so the output must be 1. So this guy spits out a 1. G of 0 is 1. Who grabs that 1? G comes again. This has nothing to do with f. Both g's get involved. G comes and grabs the x-coordinate 1 now. The new y-coordinate that was output acts like an x-coordinate now. So g of 1 says go to the x value 1, and then tell me what the y value is for g. Again, I'm focusing on the g function. Here's my ordered pair 1, 2. So when the x-coordinate is 1, the y-coordinate is 2. So g of 0 finally lands me at 2. Next thing we're going to look at is finding function compositions numerically by looking at a table. So it's the same idea. It says the table gives you some values for f and g, find f of 7. So I don't really care about the g function at all. I only focus on the f function based on what they're asking me. So I take f of 7, and then whatever that outputs, f comes and grabs it again. So f of 7 says the input or the x-coordinate is 7 in the f function. And that happens right here. What is the output? The output happens to be a 5. Now what happens with the 5? F comes in, grabs it again. Now it says go to the x-coordinate 5 for the f function, which is right here, and give me the output. Well, the output is 8. So f of f. Okay, let's find f of g of 9. So g is going to grab the 9 first, and then whatever that does, f will grab the result. So we have g of 9, I go to the g function, which is right here, and g of 9 spits out a y value of 7, an output of 7, and then f comes along and takes this 7. So now I go to the f function, and I go to the x value of 7, and it looks like it spits out a 5 for my final result. Let's do one more. Part A says f of g of 5. So again, 5 gets grabbed by whoever it's closest to first, which is g, and then f grabs that result. So what is g of 5? I have to input 5, but I don't have a function, so I just go to my table for g at the x value of 5, which has an output of 4. So 4 comes out, and then f comes and grabs 4. So now I go to the f function at the input x-coordinate 4, and that output looks like a 5. Part B, g of f of 4. So 4 gets taken by f first. I'm going to go to my f function and get a 4, which I already know the output is a 5. And then g comes and grabs the 5. So I go to the 5 x input for g, and the output is a 4.